Percent composition problems are chemical problems in which one determines the percent of each element in a given compound. With the following example, what is the percent composition of potassium permanganate, KMnO4? The first thing one needs to do is to determine the molar mass of the chemical compound. To do this, we look at the potassium. We have one potassium in the chemical equation. The potassium weighs 39.1 from the periodic table. So 1 times 39.1 is 39.1. With the manganese, we have 1, its weight from the periodic table, 54.94. So its total mass is 54.9. We have 4 oxygens. Each oxygen weighs 16. So 4 times 16 is 64. We add each of these chemicals up. We get a molar mass of 158. To determine the percent of potassium, we take the mass of potassium divided by the molar mass. We multiply it times 100, and we get the percentage of potassium in potassium permanganate as 24.7. We do the same thing with manganese. We take the mass of manganese divided by the molar mass of the compound times 100. We get 34.8 as our percentage. With oxygen, we take the mass of the 4 oxygens divided by the molar mass times 100, and we get 40.5. Now to spot check your answers, 24.7, 34.8, and 40.5 should equal 100%. If we look at a second example of percent composition, here we have sodium carbonate. The first thing we would like to do is to come up with the molar mass of sodium carbonate. So again, we have 2 sodiums, each weighs 23. We have 1 carbon weighing 12. And we have 3 oxygens weighing 48. The total molar mass would be 106. We take the mass of the sodium divided by the total molar mass, multiply times 100. We get our percentage is 43.4. We take our total mass of carbon divided by the molecular mass times 100. We get 11.3. And we take the mass of oxygen divided by the total mass times 100, we get 45.3. A second type of percent composition problem is one that deals with hydrates. Now in this problem we will be looking at magnesium sulfate heptahydrate. Now as we look at this, remember that magnesium has a +2 charge, sulfate has a -2. Crisscross, we get MgSO4. Hepta is for 7, and hydrate stands for water. So we get MgSO4 7H2O. In this problem, we are given 125 grams of the magnesium sulfate heptahydrate. All of the water has been removed, and we want to know how much of just magnesium sulfate remains. The first thing one needs to do is to calculate the molar mass. Now that we first will calculate the molar mass of magnesium sulfate. So if we look, we have 1 magnesium, weight 24.3, 1 sulfur, weight 32.06, 4 oxygens, each weighing 16. We add each of these up. We get a molar mass of 120.37. Remember that the 24.31, the 32.06, and the 16 are the weights from the periodic table. We have 7 waters. The molar mass of water is 18. we have 2 hydrogens and 1 oxygen weighing 18. Because we have 7 waters, we multiply 7 times 18 and get the water mass as being 126.1. We calculate the total molar mass by adding up the molar mass of the magnesium sulfate and the molar mass of the water, getting a total molar mass of 246.5. Of this, we take the magnesium sulfate and we divide it by the total molar mass, getting a percentage of 48.84 of this chemical compound, magnesium sulfate heptahydrate, as being just the magnesium sulfate portion. Now we do this because we are asked how much of the magnesium sulfate remains. We are given 125 grams, and so we take our percentage, 48.84, and we convert that to a decimal form. So we get 0.4884. We multiply it by the 125. We get that from our problem. Our answer, we have 61.1 grams of our magnesium sulfate heptahydrate as being just magnesium sulfate. A third type of percent composition problem is one in which the percentage of water is calculated. In this example, 5 grams of a hydrate of barium chloride was heated. 4.3 grams of the salt remains. What percentage of the original sample was water? So we start off with 5 grams of hydrate. We end with 4.3. We subtract 5 and 4.3. We get 0.7 grams was water. 0.7 grams divided by 5 grams of the total solution will give us our percentage that of that 5 grams, 14% was water. In this final percent composition problem, we are given copper 2 nitrate in hydrate. The problem is asking us to solve for N. In other words, how many waters were present. We are given a 5 gram sample of copper 2 nitrate in hydrate. This is heated. Water is removed with 3.9 grams of copper 2 nitrate remaining. So we take our 5 grams that we begin with, we subtract what we have left over, which is just the copper 2 nitrate, and we determine that 1.1 grams of the solution was water. We take our 1.1 grams of water, divide it by our beginning mass of our entire sample, which was 5 grams, multiply that times 100, and we find that 22% of our 5 gram sample was water. We take our 22%, we change that to decimal form, 0.22. We determine the mass of water to be 18. We multiply the 22 by 18, and we get 4. So we would have copper 2 nitrate with 4 H2O.